Hi students, myself Sunanda Jana, Assistant Professor, Haldia Institute of Technology. Today I will discuss a very interesting topic of computer network, error correction using Hemming code. After the end of this lecture, you people can understand what is the basic concept of computer network and data communication, and in data communication what are the factors effect, that is error, what is error related to data communication and how that error can be detected and corrected, that also you can understand. Now, before going into the details of error correction using Hemming code, first I will tell you the basic concept. In data communication system, we require always at least two devices. One is sender and another is receiver. Suppose this is sender device and this is receiver device. Now, during communication between sender and receiver, suppose sender sends some data to receiver. Now, at that moment, during transmission media problem, during transmission, suppose data has got corrupted. That means what? Suppose sender is sending the data 1101, but when receiver is receiving, it has received the data 1111. Here you can find out that 0 has altered into 1 or changed to 1. So that means what sender is sending, that original data has not received by the receiver. So here the error has occurred. Okay. So now when we want to perform any successful data communication, at that moment what we exactly require, that is the data should transmit with complete accuracy. There should not be any error. That means what the original data sender is sending, receiver must receive that original data. Now for that reason, error detection and correction plays a very major role in data communication, because for successful communication without detecting and correcting error, it is not possible. Now comes to the fundamental concept of error and different types of error related to data communication. As I have already told that during transmission of data from sender side to receiver side, if in between, because of transmission media problem or any problem, if suppose as I have already given you one example, suppose sender is sending this data, but during receiving, receiver has received some different data. So here 0 has changed to 1. So that means the error has occurred. So that means when during transmission any data bit got altered, so that is the error occurred in the data bit during transmission. Now types of error. There are mainly two types of error during data communication. One is single bit error, another is burst error. Now comes to single bit error. This is my sender side data. Sender is sending the data 10110011. But when receiver is receiving the data, here you can find out that 0 has changed to 1. So here already receiver received data is not the original data which sender has sent. So as you can observe here that the changes has done only in single bit, this is called as single bit error. Now in case of multiple bit error or burst error, if data changed in more than one bits, that is called multiple bit error or burst error. So it may be that continuous data also may change, or in between the data also may change. But when there is a change of data for more than one bits, that is considered as burst error. Now, how we will perform error detection and correction? Actually, here the process of redundancy used for that purpose. So what is the concept of redundancy? During transmitting the data, sender is generating certain functions. By the help of that functions with the original data bit, it is adding some extra data bit. That extra data bit is called as redundancy. That means for error detection and correction purpose, during transmitting the data, when some extra bits are added, that extra bit is called as redundant bits, and the process is called as redundancy. Now you can find out here, this is the sender side device. This is the original data sender is sending. Now before sending the original data, sender is generating certain code words. That means during transmitting the data, sender is sending the data with certain redundant bits. Here you can find out this is the redundant bit and this is the original data sender is sending. So that means when sender is sending, it is sending data and the redundant bits. But in the receiver side, when receiver is receiving, receiver had checker. So sender had generator which generates redundant bits, and in the receiver side, it is having checker which will use the reverse function to check that by using what function the concept of redundancy the data has added, is it obeying the same concept? If its checking is right, that means it is obeying by following the rules of the same concept, then the data will be accepted, otherwise receiver will reject that data. Or if the error has occurred in the data bit, it can find out the data error position in the data bit, or also it can rectify the data. So in that way, error detection and correction can be done by using the process of redundancy. Now, as my topic is mainly error correction, and already we have discussed error detection methods in the previous classes, so today we will mainly concentrate on error correction. Error correction can be done using two processes. One is retransmission. What is retransmission? Suppose a sender already sent the data to the receiver. Suppose this is sender device and this is receiver device. And suppose in between, the first data bit it has successfully received, and for that receiver also send acknowledgement. Okay. This is my data frame, and for that the receiver has already sent acknowledgement to the sender. Now again another data where sender is sending in between, because of transmission media problem, data has lost, or some data has got also corrupted. Then at that moment, what sender will do, it will wait for the acknowledgement up to certain period of time, and after that again it will retransmit the same data after a fixed amount of time, as sender has always a timer before sending the data. So in that way, by using the process of retransmission also, error can be corrected. And another process is called as forward error correction. By the help of forward error correction, automatically the error data can be corrected. How actually? When sender is sending the data, instead of sending the normal data, it is making the code of the data by adding some redundant bits, and after that, that code word will be transferred from sender to receiver side. Okay, and receiver will apply the same process by which that code word has constructed by the sender. It will check, and if the data has no error, then it will generate the value 0. But if there is any error in the data bit, it will simply tell us the position of the error occurred, and after that we can simply correct by knowing the position. So in that way, by using forward error correction, we can rectify error. Now, in the case of forward error correction, we have the process called hemming code. By using hemming code, we can perform error correction. So now, how we will do that? Hemming code has certain principles. First, we have to know that. Suppose we have the data of m bits. With m bits of data, we have to add our redundant bits to make the code word. Now, when sender will send the message, it will send m plus r bits of data. But whenever we will put the value of r, we have to know the relationship with r and m. So, and the value of r must satisfy the following relation. So, what is the relation? 2 to the power r must be greater than equal to m plus r plus 1. Here r is what? That is the parity bits we will add. And that parity bits also how we will add? That means in which position we will add those parity bits? That is by considering the power of two positions. That means here you can find out the parity check bits are assigned position numbers that are power of 2. That means in first position, second position, fourth position, eighth position, we can put those parity bits. So you can find out here the pictorial representation that this is my m bits of data and r bits of redundant added, and during transmission m plus r total bits will be transferred. Now suppose consider that we have 7 bits of data. Okay, with 7 bits of data, how many redundant bits we will add? Then we have to go to that particular relation. From that relation, we can calculate the value of r. So, if we will put the value of r, that means if we will add one redundant bit, you can find out that this relation is not satisfied. So, if we will put 2 here, for 1 it is not satisfying the condition. If we will put the value 2, then also it will not satisfy the condition. If we will put value 3, then also it is not satisfying the condition. But if we will put the value 4, we can find out that this condition will satisfy. So that means here for my 7 bits of data, we need 4 redundant bits. Now that redundant bits also we have to put in which position? That is multiples of 2 or 2 powers position. So that means first will be 2 to the power 0 position, that is 1 position. Then 2 to the power 1 position, that means this second position. Then 2 to the power 2, that is 4th position, and 2 to the power, then 2 to the power 2, then 2 to the power 3, that is 8th position. So in that way we will put the redundant bits with my data. Now how we will calculate those values? That means after putting that redundant bits, we have to also calculate the value of that R1, R2, R3 and R4. There are also certain format by which we can easily get the idea. Actually here we will go for binary coded decimal conversion, and here how Hamming codes and those redundant bits value we can calculate. You can find out this is 8421 format for converting any decimal number to its equivalent binary number, and for 0 you can find out that is 0000, for 1 that is 0001, and in that way as total we have 7 plus 4, that is 11 bits of data. So for up to 11 position we have calculated or we have converted decimal to binary. And after that for R1, which values we will consider? That is, you can find out this position is having 1, then here 1, 1, 1, 1, 1. So for this column, we will consider those positions whose values are 1. So you can find out this is 1, 3, 5, 7, 9 and 11. So here for calculating the value of R1, we will consider those positions. For R2, in the same way, we will take second position, third position, then sixth position, seventh position, 10th position and 11th position. Okay, and in the same way we will calculate for R3 and R4. Now in this here also those concept has elaborated given, that is for R1 how it will be implemented, for R2 how it will be implemented, and how we will track those positions. Here it is given. which I have already discussed in the tabular format. Now, with one example, I will explain that how exactly Hemming code is constructing the code word, and how sender is sending that code word from to the receiver, and how again receiver is checking, and if data has error, how it is exactly telling the position. Okay, so this is my database. Suppose consider that is 1001101. Now, as I have already told that we will put in the first position R1. Now, how we will calculate the value of R1? Already we know for calculating R1 which positions we have to consider. That is that already we have already discussed. That is 1, 3, 5, 7, 9, 11. Now, you can find out 1, 3, 5, 7, 9, 11. Okay. So this is 11. Okay. So now to calculate the value of R1, because R1 is the redundant bit whose value we have to calculate. Here we will use the concept of parity, that is even parity. Even parity concept, how will we add? We will calculate here the number of ones. Okay, and if the number of 1 is odd, we have to make it even by adding extra 1. And if the countable number is already even, then we will place simply 0. Okay, so for R1, you can find out that initially that in the R1 position, it is R1 and this is R2. This is R1, 2, this is R4, R8. Okay, and in R1 position, 1, 3, 5, 7, 9, and 11. Those positions value we will consider. So one position's value, that is redundant bit whose value we will put, and you in the third position, what is the value? That is 1. In fifth position, that is 0. In the seventh position, that is 1. In ninth position, that is 0. And in 11th position, it is 1. Now you count number of ones. 1, 2, 3. So that is odd number. So to make it even, we have to add 1 in the first position. So that means the redundant bit R1's value will be 1. So you can find out that it has already given here the value 1. And in the same way, we will calculate the value of R2, R4 and R8. You can find out for R2, it is obeying the rules of even parity. That is, after counting the number of ones, here the value is already even. So because of that, we will simply put here 0. And for R4 also it is 0 because the number of ones, that is already even. Now in case of R8, if we will count the number of ones, that is odd. So to calculate the value of R8, we have to put 1. So because of that, the value of R8 will be 1. So in that way, finally after adding all the redundant bits with the data, we will get the code word. This is my code which sender has generated, and from the sender side, sender will send that particular code to the receiver. Now at the receiver end, suppose let's consider, as I have already told, that if no error is there, so in the receiver side, when checker will check, it will generate the values as all zeros. Okay, but if there is any error, then it will detect that particular position of the error. Now suppose consider that during sending the data, some error has occurred in the database. And here, as you can find out, that 1 has changed to 0. Now we have to find out First we have to find out what that is error has occurred or not. If error has occurred, it will also find out the position of the error. Then after getting the position, obviously if we change the value, then error will be automatically corrected. Now in the receiver side, what receiver will do? Receiver will also check the value of the redundant bits R1, R2, R4 and R8 in the same way. So for calculating the value of R1, it will do the same thing. It will go for the position 1, 3, 5, 7, 9, 11. Okay. So for 1, 3, 5, 7, 9, 11, if we will calculate the value of ones, in 1, 3, 5, 7, 9, 11. Okay. Then what is the value there? In first position, this is 1, because in the receiver side it has already generated 1. Then in the third position it is 1, in the fifth position it is 0, in the seventh position it is 0, in the ninth position it is 0, and in the 11th position it is 1. So number of 1, if you can count, that is 1, 2, 3. It is not even. If it is not even, then to make it even we have to add 1. So that means here the value which has generated for R1, that is 1. So that means here the value generated is 1, which is written here. Now for the next case also we will go for the same thing. That means checker will check in the receiver side that the value of R2 is following the concept of even parity or not. So for R2 it will go for checking the positions value of 2, 3, 6, 7, 10 and 11. Now if we will go for checking the value, that is in the second position it is 0, in the third position 1, in the sixth position 1, seventh position 0, and 10th position 0, and 11th position 1. So if you count here number of ones, it is what? 3. So that means it is not obeying the concept of even parity. So to make it even, we have to add again extra 1. So here the 1 will be put here. Okay. So that means for R4 also the same thing we will use. So for R4 the position we will consider what? That is 4, 5, 6, 7. So in 4, 5, 6, 7, if you count number of ones, that is 1. So to make it even parity, R4's value will also be calculated as 1. Now R8. For R8 it will consider 8, 9, 10, 11th position. And here if we will check the value of R8, it is obeying the concept of even parity. So its value will be 0 because no need to add extra 1. It is already obeying the concept. Now if we will convert this number into decimal values, we can find out that the value it is producing is 7. So that means it is telling that in the 7th bit position there is error. Now we will simply receiver will simply check that one, and whatever value was there, it will just alter that value. And if we will alter that value, so obviously the value will automatically be corrected. So in that way, by using Hamming code, single bit error can easily be traced and as well as corrected. So how it is tracing? It is tracing the position, particularly in which position the error has occurred. And after that, if the receiver will alternate the value, then automatically the error will be corrected and original data will be received by the receiver. Now student, if you have any query, then you can ask. Thank you.